So let me do this in blue. Example, 750 milliliters of a 3.0 times 10 to the negative 3 molarity silver nitrate solution is mixed with 300.0 milliliters of a 2.5 times 10 to the negative 2 molar potassium chloride solution. Will a precipitate form? Okay. So notice earlier we were talking about just taking a certain solution and dropping some solid into it and seeing how much dissolves. Excuse me. Now what we're doing is we're taking some solutions of free ion, we're mixing them together, and if a couple of those ions form insoluble salts, we want to find out, based on how much of each free ion there is in there, if an actual solid will drop to the bottom, if a precipitate will, suddenly appear. So let's draw this out. We have a solution, we have 750 milliliters of a silver nitrate. So this is a silver nitrate solution, AgNO3. Well, we know that things that have nitrate in them are completely soluble. So what you have is free silver ion and free nitrate ion floating around. It just looks like some water because it's fully soluble. Now we also have another solution. We have 300 milliliters of this potassium chloride solution. Well, potassium chloride is also a completely soluble salt. So we write KCl as a solution, but really what you have is free potassium and free chloride. It's fully dissolved. And again, these are not saturated solutions. There's no solid anywhere. These are just, solutions of potassium chloride and silver nitrate. Now what we do is we mix them together, okay? When we mix them together, now what we have is, well, 750 plus 300. Now we have 1,050 milliliters of the KCl and the AgNO3 solution mixed. Before any reaction takes place, what you have is free silver ion, free nitrate ion, free potassium ion, and free chloride ion. These are the major species in solution. And again, major species. Let's take a look at these major species and let's see if a reaction is going to take place. Well, silver nitrate, if they slam back into each other, they're just going to dissolve again. They're fully soluble. If potassium and chloride ion slam into each other, they're just going to dissolve again. That doesn't matter. Positive and positive, they're not going to, when they slam into each other, they're just going to bounce right off. So the only two possibilities is potassium and nitrate coming together and silver and chloride coming together. Well, potassium nitrate is also soluble, so if they slam together and they stick, it's just going to dissolve again. But silver and chloride, when they slam into each other, the KSP, let me see, the KSP happens to be, let me actually write it here, KSP of AgCl equals 1.6 times 10 to the negative 10. Well, we know from our solubility chart that it is insoluble. So when these slam together, chances are they will precipitate. However, we need to find out if they will precipitate based on these amounts. These concentrations of free silver and free chloride, they have to equal, the product has to equal the KSP before something will precipitate. Remember? That's the whole idea. If it's equal to the KSP or bigger, it'll precipitate. If it's less than that, it hasn't reached the KSP value. Therefore, it is not a saturated solution. The ions are free. There is no precipitate. So in this case, if we didn't know from our solubility chart that this is insoluble, we can just take a look at the KSP. You know that this is one of the possibilities that AgCl may precipitate here because we're looking at a small KSP. Okay, so let's actually do the math. So now let's go ahead and write out the possible reaction. AgCl is going to be in equilibrium with Ag plus Cl minus. It's 1 to 1. Our KSP expression equals Ag plus Cl minus. Our QSP is equal to the initial concentration of Ag times the initial concentration. It's the same as that except initial concentrations. Now let's calculate this. We'll calculate this. We'll multiply them together. We'll see what we get. Let's rewrite the KSP on this page. KSP equals 1.6 times 10 to the negative 10 for our reference. Okay, let's go ahead and move on to blue. So the silver ion concentration is going to equal, well, concentration is moles per liter. The total number of moles of silver in the total volume. Well, the total volume has changed. I added 750 milliliters to 300 milliliters. So now that silver ion is not just floating around in 750 milliliters, it's floating around in 1,050 milliliters. I need to know how many moles that was. Well, we had 750.0 milliliters of a 2.0 time, I'm sorry, that's a 3.0, not 2.0. Volume times molarity, 3.0 times 10 to the negative 3 millimoles per milliliter. That's going to give us moles, millimoles, over the total number of liters, total number of milliliters, total volume, plus 300 milliliters, right? The moles of silver divided by the total volume that it's floating around in. You end up with 2.14 times 10 to the negative 3 molarity. Now let's calculate the initial chloride ion concentration. Well, it's equal to the total chloride ion and total volume. Well, the initial chloride solution, we had 300 milliliters of it, and the molarity was 2.5 times 10 to the negative 2 millimoles per milliliter. When you multiply those two, that'll give us the moles of chloride ion that we started off with in the second beaker, and now we've mixed them, and again our total volume is 750 plus 300 milliliters, and we get 7.14 times 10 to the negative 3 molar. Well, QSP is equal to that times that, right? This expression, and there's no exponents, so we're okay. So it's going to be 2.14 times 10 to the negative 3 times 7.14 times 10 to the negative 3. That equals 1.52 times 10 to the negative 5, which is definitely bigger than the KSP, which is 1.6 times 10 to the negative 10. So yes, AgCl, a little arrow pointing down, is an old symbol for a precipitate, will precipitate. And that's it. So this is a nice quantitative method of letting us know whether something actually will precipitate based on the product of the ion concentrations. If it is bigger than the KSP, then yes, a precipitate will show up. If it's less than the KSP, well, KSP measures equilibrium, something that's in equilibrium with the solid from which those ions come from. If these numbers multiplied together is less than the KSP, well, that means there is no solid for there to be any equilibrium reached. So, okay. Thank you for joining us here at Educator.com to discuss solubility equilibria, and we have one more lesson to discuss that same subject. See you next time. Bye-bye.